Hello, everyone, and welcome to this interview with Jonathan Blow. So Jonathan Blow is a famous game developer who has also recently became famous, or infamous maybe, for his work on a brand new systems-level programming language called Jai.
Well, that's not even the official name, actually.
It's not?
It doesn't have an official name.
Okay,
Yeah.
without an official name, in
Yes.
fact. And so today here I'm very pleased that he has decided to join us and allow me to interview him. And if we have time at the end, then we'll take audience questions. So first off, Jonathan, give us your best elevator pitch for this unknown, unnamed programming language that you've been working on for the past 10 years.
Wow, I am totally unprepared for that. What I'll say is the reason why I felt that I had to make it was that I looked around at all the languages that were being made, and I felt like none of them addressed what I needed, right? Which I felt was really something that a lot of people needed, which is just a solution to their actual practical problems. Like, it takes so long to compile my program, or I go into work and I'm just depressed by the prospect of having to work on this thing, or I don't understand my program, right? Or, all these things. And I mean, when people propose their idea for a new programming language, it's intended to solve problems like that. And then what I saw was year after year of a certain, let's call it paradigm of thought of what's a good programming language, was producing all these languages. And none of those languages seem to address the world that I lived in, which is I want to make high quality software with high efficiency per programmer. So not like giant teams, but like 3 or 4 people programming something that millions of people are going to use and enjoy. And so I just have been designing it to address the reality that I perceive and that I live in.
Fantastic.
Yeah.
So if I could distill that into an elevator pitch, correct me if I'm wrong, it sounds like the reason to use, may I call it Jai, even though Jai is not the official name?
Sure.
Okay.
Yes.
The reason to use Jai is you want to write really fast code, and you want to be very productive doing that on a day-to-day basis.
Yes. But we can go into a bunch of other things, right? So part of it is a little bit reactionary, I would almost say, to assumptions that very few people question that affect all other programming languages, which is why I looked around and I was like, I had been programming in C++ before this.
Yes.
And, it's not...
One of my first languages, and it's gotten to be a beast over the years. I'm
Yeah.
no longer a fan of that
Well, I
language.
pressed pause around C++ 11. I don't really use any features from after that. But even so, it's got a bunch of problems.
Yeah.
But I look around at everything else in the world and it's like, okay, this language has a bunch of problems, but it's still the best option. And why is that? And it's because everybody's off in other spaces doing other things. And so I was like, okay, wait, let's go back to this model of language, but let's actually do what we know is better than this C++ thing, right? And there's an unending list of things that you could do better.
Yes.
Right, but
I'm going to ask you about some of those in a second.
I actually had some other point, and now I've forgotten about it.
Well, if it comes back, you just interrupt me.
If it comes back, we'll... Yeah.
So philosophically,
Yeah.
which other programming languages, systems programming languages that are fairly new, would you say are closest in spirit to Jai, if anything?
Oh, very few. Oh, well, I just remembered the thing I was going to say, which is one of these unquestioned assumptions, right, is that the development of software is some grand endeavor in which we all participate, and we're building some giant tower into the heavens, right, that gets ever taller, and there's ever more layers in this software stack.
Enterprise software development.
And that's a great thing, and you shouldn't write left pad yourself. You should use something provided by somebody on NPM, and all this. And but that goes counter to everything that I understand and believe in. Like, what I feel good about code when there's not very much code, when I look at it and it doesn't send me into convulsions just aesthetically
It would be
looking at
most
it.
of modern enterprise code.
Yeah, well, and when I can read it and understand it. And most languages seem to be designed according to some idea where that's just off the table now, right?
Yeah.
And so, yeah, I mean, so to your question about what else, was the question what else is in the same family?
Yeah, what other sort of newer systems level programming languages, or at least
See, here's the problem.
closer than
For this audience,
Java.
So one of the basic tenets of this language is absolutely not garbage collected, right?
Yes.
And so that puts it very far apart from most languages.
systems
people are
level
discussing
programming
here.
language?
So of things that people are discussing here, Rust would be the closest one, but we're
How about
very
Zig?
far from. I haven't followed it that much, so I couldn't tell you very specifically, but those are probably, broadly speaking, in the same family. But
Okay.
it's one of those things where if you're not in that world, those all seem very close together probably.
Yeah.
But if you're in that, they're all super far apart.
Yes, makes sense. You make an interesting point about how I'd never really thought about this before, but for games, it's write once code bases. Unless there's a sequel
That's
that
not really true.
there's a sequel,
but
as
it
there is for Braid.
It is, because for several reasons, that's not quite true, because we often will use our engine
Engines,
code, which is
yeah.
often much of the gameplay, to do the next thing. But there is a flash freeze kind of thing where we push the button, that's what goes out to people. And then we don't have to worry about that exact thing anymore. We can rip stuff out and make it better or whatever.
And I wonder if that has affected the design of this language in any way.
A little bit. But it's a little more holistic than that. It's more just designed, you've got 3 or 4 programmers. I mean, we're not designing it not to scale to bigger teams.
Yes.
But the point being, if you have 3 or 4 programmers and they're all highly productive people, you should be able to make, I don't know what percentage of the software that you hear about in the world, but a large percentage of it.
Yes.
Because a lot of this software really isn't actually that complicated,
Yeah.
especially if you're building on stuff that's come before and all these algorithms have been figured out. You don't have to figure them out. You just
Yes.
have to type things in sometimes. And so,
That philosophy is very similar to Clojure, of
Yeah.
sort of totally different language, different audience entirely.
Yeah.
But also Clojure has this goal to help a small number of high-skilled programmers be extraordinarily productive.
and where that comes into play concretely in language design is, for example, you'll talk to somebody about a design of some other language and I don't know, maybe Java, maybe something else, and you ask why is this feature chosen to be this way? And they say, well, if you don't do that,
The programmers are going to screw up, right?
when the junior programmer comes onto the team, he's
Yes.
going to cause very bad things to
Yes.
happen, and it'll be a great deal of damage and whatever.
Yeah.
And I'm just that's fine. That's some kind of defensive language design that affects many languages. And the way that I think about that, it's equivalent. Say you're trying to be a chef. You're trying to be a really good chef, right? But the guy who designs the machines at
knife.
McDonald's comes in and says, no, the way this works is you push the button and it cooks the fries for
Yes.
1 minute, because that way you can hire someone from
Yeah.
high school and they can make all the food.
Yeah.
And it's okay, that's an interesting problem to solve, maybe, but that shouldn't be every programming language,
Yeah.
first of all. And then secondly, we should have an awareness that there's different kinds of programming, right? Just like there's different kinds of driving. Like if you're a Formula One driver, you're not doing what I do to drive here to this hotel. It's a different thing. With programming, it's also a different thing. And I think we should, acknowledge that
Yes.
and try
Have
to design
languages
that.
for high-skill people
Yeah.
who have a lot of experience in industry, and they want the tools. They are the
Which,
chefs.
by the way, as soon as you say something like that, some people get very reactive. Like, are you saying not all programmers are equally good? Yes, but
Fact.
but
Hard
that's
fact.
that doesn't have to be like a conceited thing
No,
or a bragging thing.
no,
it's an
yeah.
observation about the world.
Exactly.
Like, I played tennis when I was a kid. I'm not a good tennis
Exactly.
player. I don't want to play Bjorn
We are
Borg
not
or
all
whoever.
equally good at all things.
Yeah, no, and on the other hand, if somebody spends 10 hours a day for 30 years doing something, you expect them to be very
Yes.
good. And this is obvious and natural,
Yeah.
and we shouldn't ignore
Yes.
that culturally.
Yeah, I think so. I think
Yeah.
you're exactly right. So you've mentioned before that Jai is designed for programmers who like to program. So what are some of the things that you enjoy about programming that have made their way into Jai?
You know, it's hard to answer that question in exactly that way because it's more about, like the nice thing with programming is you have an idea, you want to go try out the idea, you get an initial version of it relatively quickly, even if it doesn't do everything you wanted, but you're like proving out the concept. You're like, oh, this is the basic shape of the thing. You can see it operating. You can make changes relatively quickly, and those changes can show up on the screen or wherever as a obviously improved version of the thing. And that iteration process, right, is joyful when it works well. And of course, at some point, you know, like programming being what it is, eventually you get bogged down. You have all these either constraints from the rest of the system or from within your own system, and you start making more bugs, right? And it takes longer. But in that initial period, which I would like to extend for as long as possible, when you can just type things in and they work with relatively little hassle, and your compile, edit, debug cycle is very fast, right? Like in 3 seconds, I can be back up and running or whatever. That's magical and enjoyable. And it's like what it was like when I was a kid in front of a home computer, you know, running BASIC, and I was reading the little book and I'm learning BASIC, and they're like, 10 print, hello, 20 go to 10. But it's so fast to type that and see it, right?
Yeah.
I mean, how even the equivalent of 10 print, hello, 20 go to 10, like, if you just open a Dell computer out of the box, like how long does it take you to get there, right?
A long time.
And this is a problem, and I don't know, we need to take it more seriously.
Yes, agreed. All right, so can you explain a bit Jai's approach to polymorphism and generics?
Okay, yeah, they get kind of complicated eventually, but
and why you chose to go down this path as opposed to like Java or C++ or Haskell?
I very definitely wanted absolutely zero runtime overhead, right? So there is no runtime polymorphism mechanism at all. Everything is compile time. And so it's built on top of and heavily intertwined with all these other mechanisms that a programming language tends to have, like, you know, overload resolution and all that kind of stuff. And then there's other features, because it's all about essentially, you know, taking one more general or abstract declaration of a function, right? And first you take that signature and you solve for what you're solving for, and you bake down constants. So, you know, we have a version of currying in this language, but it's fully compile time, right? So you can okay, so every function is interchangeable. Polymorphic and non-polymorphic are interchangeable in terms of like the language semantics, which is unusual for a C++ style language, right? C++ has a whole other programming language that you have to use to do generics, right? This is just like, okay, a function signature could have polymorphic variables in it or not. And if it does, we have to solve for those. And in the process of solving for those, we might do other things like baking in constants or something like that.
Yeah.
Right? And what comes out is just a fully baked function that is just as compile time as anything else. And you can actually query for that function and stuff. So you could say like, what would be the version of foo that I would get if I called it with these arguments, and it does the polymorph and gives it back to you, right? It's not super common to use that, but you can do that.
Interesting. So you would say that desire to have zero cost at runtime is partially what motivated
Yes, but as always in computers, zero cost, you have to put quotes around it, right? Because
more code.
Well, yeah. So you know, now we have 37 versions of some function, and that does have a cost. And so we have some other mechanisms for trying to deal with that. But yeah.
Okay, fantastic. So Jai allows running arbitrary code at compile time. So what's the rationale for that? And what are some of the things that it enables you to do that you couldn't do before?
Well, the very initial rationale was like, why hasn't anyone ever done this?
I know,
Because
right?
we have all these languages that run a virtual machine, and a virtual machine is just bytecode instructions, and that's also the standard in any modern compiler. That's now the main intermediate representation that people use right before lowering the machine code, right? And it's like, you can compile that, you can run it. Why doesn't anyone ever compile and run? Even very generalized libraries like LLVM doesn't really do. I think some people have hacked some weird stuff together,
Yeah.
but it doesn't really work. So we have some very cheeky demos. Actually, in the early days of the compiler, I had some very cheeky demo where I would run some video game while you're compiling, and you had to kill 10 aliens, or it would refuse to output your executable. So that's the extent of compile time execution that we're talking about. You can
Literally
you can
do
render
anything.
graphics, you can talk over the network, you can do whatever you want. It has to run exactly the same code, which again, to somebody heavily buried in theory is no surprise. Like, obviously,
Yes.
you could map the program either of these
Yeah.
ways, but like somehow nobody has done it. Now, this is something that a lot of people on the internet take issue with, because they're like, oh my God, what if you're running untrusted code during your build process or whatever? And it's just like, yeah, that's not really something I'm worried about in my
Tools
use
for
case.
high-skilled programmers.
Right, but B, this is also like, yeah, it makes it a lot easier probably to do something exploitable, but at the same time, I mean, nobody's vetting all these make files that are flying around and
Yeah,
all this stuff, and those are
yes.
Turing equivalent, and
Yeah.
like, so it's kind of, and in fact, we had some high-profile stuff that happened just a few weeks ago that was about hiding stuff in make files, right? And I'm sure if you really look, there's a lot more stuff hidden in make files. So. I don't know. That's sort of that's a thing that open source people worry about. That is not really my main concern, because what I'm looking at is like a team of people who
Yes.
you hopefully mostly trust,
Yes,
working
Trusted,
together to
high-skilled
build a
people.
common thing.
Yeah.
Yeah.
makes sense. And Jai also has this interesting feature built-in build process that is quite unusual.
Well, it's actually exactly the same thing.
Oh,
it's
it
just
is?
the compile time. Okay. Well, it's two things together, right? So one thing that functional languages got right from the beginning, right? Got to throw a bone to the functional language people at the conference.
Everyone here appreciates that.
Is this very basic idea that your program is a mathematical object that is essentially defined by the program text, right? And then converting that program text into whatever you're going to run is a mapping that's well defined, right? And that there's no ambiguity about. And then somehow, all these other languages never absorb that. So like for a C program or a C++ program, that's in theory true. But you go to compile the program and you have like all this linker stuff going on and whatever, and it always causes failures. And the system just affects your program in a really unsavory way, which like doesn't make sense if your program's a mathematical object. Like, what is all that? Why is this stuff breaking you all the time, right? And so just like an old Lisp program or something, you load your top file and it loads all the other files and they just compile and it figures out, there's a dependency solver that figures out what it can compile next, and it sort of propagates through the code. So there's none of this stuff that you have in a lot of languages where it's like you have to, the ultimate example of
Separate it
this
into
again is C,
different packages.
where you have header files, but there's also package compile order and stuff. We don't have any of that. That has given me some gray hairs, but we don't have any of that.
Better you than every single user of the programming
Yeah, well,
language.
that's the thing, is these ergonomics are important,
Yes,
right?
yeah.
And so that's the thing, is you don't need to do anything to build your program. You literally just have your first file and it can load some other files and that's it, right? Which I think is very good and is nothing new to us. Functional languages have been doing this forever. In part because I think, again, this is a longer talk maybe than for this, but there's some very powerful features that happen to get implemented in languages mainly because those languages were interpreted originally, and then if you made a compiler for it, the compiler author would sweat hard to figure out how to do like the good introspection or reflection or whatever you want to call it at compile time, right? There are certain features that are natural to interpreters, And that's why those features tend to be lacking from like languages like C or Fortran that always started compiled, right? Because it was hard for them. And so that's some of the elbow grease that I've done is like implement those things in a compiled setting, in a language made for compiled. Wow, I've drifted pretty far off the question.
No worries, no worries. It was all interesting.
Yeah.
So every functional programmer would probably be curious about what are your thoughts on Lambdas, which capture over state and some types.
We do have a very low effort form of subtypes that we implemented that I'm just going to see how it is. But we're not a very type theory kind of place.
Sure.
And but the Lambda question is more specific. You know, I thought originally that I would implement them relatively quickly. And we just haven't needed them for anything. Like a certain percentage of the feature development is just driven by what we need for the software that we're making, and we just haven't needed them. In part because of this compile time, function changing that we can do. It covers certain aspects of those use cases, and then there are other, so one of the trouble spots you get into in C, for example, if you don't have lambdas, is you write all this code, you call like qsort or something, and it takes a callback, and the callback has no data pointer, right? And then, so you're using some global variables, and then you try to thread this code, and it mysteriously breaks because blah, 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 right? Yeah. And so we have other facilities for that, for providing easy access data that's per thread. But still, there probably are a few cases where they would be useful. So it's actually on the roadmap.
Okay.
Like in a threaded environment. So our base, like what a function is in this language right now is not much different from C. It's just like the pointer to the code of the function, right? What we're going to do, because even if you're not doing a Lambda specifically, even if you're just doing a C-style callback or something, like you pretty much always want a data pointer. And so you end up with all these functions that pass 2 arguments. Right, and then you could maybe get them confused and get them wrong and whatever. And so our basic function type is going to be function pointer and then data pointer standardly. Yeah. And then if you want a more efficient just the function pointer, you could put a little directive, and then they'll implicitly cast back and forth. And then a lambda would be syntactic sugar on that, and then plus the question of how do you manage the memory for the storage.
Big question.
But it's on the roadmap, but does not exist currently.
Okay, fantastic. So where is Jai at right now? Would you recommend developers try to build and deploy an application with Jai?
They can't because we don't give it out yet. We have a closed beta.
That makes it easy.
Yeah. No, and part of this is this being contrarian. So a lot of the damage that I feel like has been done in the world, both in languages but also just in software generally, is somebody learns just enough to make some piece of software or whatever, and then they put it on the internet, they put their name all over. It's like tagging buildings, right? And I got my name out there, and I'm famous now for this thing, and then this thing is low quality and has all these bugs and is not that much better than this other thing that already existed, right? My favorite page on Wikipedia is, I forget the exact name, but it's something like Graph of Linux Distributions, right? So you go to that page and you look at this giant mega spaghetti graph of all this stuff, and it's all this wasted, duplicated effort that mostly has come to naught. I mean, Linux obviously is successful to some degree, but we could, in a longer forum, we could debate about to what degree. But then software generally is always doing that. And so the internet is flooded with all this low quality stuff. And the problem is once you make something public and have a bunch of people using it, it's very hard to change your decisions. Yeah. If you made a suboptimal decision, now you're stuck with it unless you do version 2 of the language or something. And so I'm keeping it under wraps for a long time. Just to keep iterating on those decisions and try to make them good. And it's hard because it is like a C++ competitor language, so it's got a ton of features in it. Yeah. And that just,
takes a while to get right.
Yeah. The one feature that is not quite, I think most of them are good except bugs, but the main feature that I'm fundamentally not happy with is we have a version of Lisp macros in a compiled language. Yeah. They don't totally work that well. They're just not that nice to use, and they're not as as magical as they should be.
So macros might be overhauled at some point before release.
Yeah, but we have a closed beta with something like 650 people in it.
And there's a guy who wrote a book, or the book's not done, but
Is that true?
that is true.
I've been
There's a
busy
book on
working this
using
game.
Jai.
Okay, cool.
That's where I learned everything I know about the language.
All right.
Okay, so 2 more questions, and then we might have time for 1 or 2 audience questions real quick. Oh, we have no time. We're out of time. Okay. Well, then I'll ask you 1 more question.
Yeah.
How do you hope that Jai is going to impact the future of language design?
I'm not sure. Originally, I was like, of course, I want to release it and have it be really popular and have tons of people using it. But like the best bands aren't the most popular bands or whatever, right? So maybe that's not the goal. But right now, I'm actually doing it the same way I design a game, which is I'm not that worried, because if you worry too much about commercial success, or the programming language version of that is appeal to a very wide range of people, it affects your decision making, obviously, and then sometimes you might not have the courage to make decisions you would otherwise make.
Yeah.
So I'm kind of ignoring that. I had assumed, we did our first closed beta in 2020, which is a while ago now.
Yeah.
So I would have assumed by now it would be open to the public, but I just keep wanting
Didn't
to
feel it
make
was
it
right.
better.
Yeah.
And so if I can make the best thing and some people use it, I think that's pretty good.
Yes.
We'll see.
That's the Haskell philosophy, albeit for functional programming.
Yeah. Yeah.
All right, well, thank you so much for coming here.
All right.
And I'm sure if you have questions for Jonathan, he'll take them
I'll
in the
be
hallway
wandering
chat.
around. You can waylay me.
Thank you.
Thanks.